So you're back for more. Today we're talking about changing the amplitude, period, and phase shifts. Basically, these are any transformations of the sine and cosine graph I taught you yesterday. So, not going to completely reteach yesterday, but I hope you remember that sine goes like that, and it goes forever in both directions, left and right, and that means its domain is all reals, and its range is from -1 to 1. All right, you need to know that, because when I tell you, oh, by the way, now it's got a amplitude of 2, you got to be able to know what it looked like in the first place so that you can just make it go twice as tall. Or, for instance, if I say we need to have a stretch factor on the inside, like for instance, y equals sine of 4x, you have to know, oh, okay, that's on the inside, so we don't trust it. We don't multiply everything by 4, we multiply everything by 1/4. And that means all of these on the bottom are going to be multiplied by 1/4. So when I go 1/4 here, that's going to make this pi over what? 1 times the pi, 2 times the 4, pi over 8. All right, so then I'm going to go in here, erase this, and say pi over 8. And this is multiply everything by what again? 1/4. Multiply by 1/4 would make it 3 pi over 8. And multiply by 1/4. So 2 pi over 4. Simplifies to pi over 2. All right, so there's an important formula that goes with this. The period is 2 pi over b. Why is it 2 pi? Because sine and cosine's period is 2 pi. And so if you know the b term is 4, that's that 4 right there. That goes on the bottom. So it's right there. So then our period has now changed for this function. It's changed to simplifying 2/4 into 1/2 pi over 2. So this became pi over 2. And now our sine function still looks like this. But since I've relabeled the axis, it's effectively gotten shrunken because the number's on the inside. It seems like it's going to make it 4 times wider. Actually makes it 4 times narrower. Okay? All right. There's the big overview. Now, reminder, the amplitude is here. Sometimes they call this baseline. I like to call it the midline. It goes right through the middle of your trig function. And this right here is the vertical shift, also known as the midline. So if you have moved something like y equals cosine of x plus 8, you've moved it up 8, then that means it's baseline or midline, the line that runs right through the middle of cosine, will have moved up 8. So the whole function moves with it up 8. All right, so quick reminder again, this is your amplitude. This, we just usually call it the b term. It messes with the horizontal. That means when we are graphing it, we have to change our horizontal numbers. Next is c, that's the phase shift. We'll talk more about that today. And d, which is the vertical shift, which also is the midline, or as they said earlier in the notes, the baseline. Okay? All right, so what if, for instance, you had to graph this? That part's super easy. Instead of going from 1 to -1, your new graph will go from 3 to -3. And now, what about that? That's supposed to be 4 times theta. That is our b term. Period is 2 pi over b, and our b is 4, so our new period will be pi over 2. I'm simplifying this into pi over 2. Okay, so that's our period of this function. That means it ends at, instead of 2 pi, it ends at pi over 2. What I think the easiest way to do it, though, is to just label the original one and label all the spots that it would have been. You would have been doing these. There's 5 spots, 0, and then this is 2 pi, and then this is halfway to 2 pi, which is 1 pi. This is pi over 2, 3 pi over 2. And now, because there's a 4 right here, I'll use my fancy pointing tool. Because there's a 4 right there, I now have to change all of these numbers, that and this and this and this, to reflect the fact that we don't times by 4, seems like it, but because it's on the inside, we do the opposite. We multiply everything by 1/4. All right, so that's going to, I'm going to go through and imagine that I times everything by 1/4. So then I'm going to make denominators under everything. And when I times this first one by 1/4, it was pi over 2. When you times it by 1/4, it's pi over 8. This gets times by 1/4. This gets times by 1/4. It was 3 pi over 2, and the 2 times the 4 makes 8. And then this gets times by 1/4. All right. So there, I've labeled it all, and now the nice part is by doing it with labeling like that, all I have to do now is draw in our sine wave. There. So, period is 2 pi over b. We've talked about that more than once. That's an important thing that relates this number on the inside here to what the period will be. Now let's talk about this phase shift. I'm going to have you just look at this for a second. What if I said y equals sine of theta minus pi and then plus 1? Well, this has 2 things happening. A shift to the right of pi, that's called the phase shift. And this, which is a vertical shift. Okay, so if this one's a vertical, because it's vertical on the outside, this one's a horizontal shift. And you may remember that negatives in there mean it shifts to the right. Seems like it's going to the left. Can't trust the stuff on the inside. So this would take your normal sine graph, which would have started off looking like that, and shifting it pi to the right. Well, if this is normal sine, pi is right here, and 2 pi is right there. So how far should I shift it to the right? I should shift it pi to the right. So everything here, I'm going to just start it over again. This graph, if I could draw it on top, pausing for a second. I know you guys in Notability can use a little lasso and you can drag something over. If I could, I would grab this and I would drag it over to the right. So instead, I'm going to have to move it. How far? That far, because that's how far pi is. All right, so now it's going to go like that. So it's no longer here. I'm going to erase this one. There, I just dragged it to the right. Notice I left my my labels in there, and so I still have this spot right here, which was pi, and this is still pi over 2, and this would be 3 pi over 2, and this would be 2 pi, and then there's be a couple more spots here that you have to label. Now, the easy way to label this is to say 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, that spot's 5 pi over 2. And this spot will be 6 pi over 2. That's why I say I'm not going to be too harsh on not reducing, because 6 pi over 2 obviously is the same as 3 pi, but it'd be a lot easier to do it that way. All right, moving on. Oh, before I completely finish that topic, I'm going to say, what if your function looked like this? Because this is going to happen to you for sure. You have a let's say a 2, and then there's a theta minus pi, like that. And we tell you, okay, that's all a horizontal changes there. That's a horizontal, seems like a stretch, actually a shrink, and it's a move to the right. But to get a phase shift, you have to factor out this 2. So the 2 gets factored out. What do I have left? theta minus, and I don't know if you know how to do this kind of factoring, but when I'm factoring out a 2, what I'm really doing is dividing both parts by 2 and seeing what I have left. Do you see how this original right here turns into this? All right, so I'm gonna change my problem then to cosine of that. It's the same thing. It just tells you what the phase shift is. You would have probably thought the phase shift on this one was pi, because, oh, isn't that the thing that's on the right? But you have to factor it out first. Remember me saying if you can factor it, you should? Another good example of that. So your phase shift on this one would be right pi over 2. And your horizontal seems like a stretch, actually a shrink. Means you'd multiply everything, all your numbers that go along here, by 1/2. Okay, so your normal numbers are 0, pi over 2, pi, 2 pi over 2, 3 pi over 2, and 4 pi over 2, which is 2 pi. And I'm going to multiply all of those by, not 2, 1/2. So that makes this over 4, multiplying that by 1/2. Makes that over 4, multiplying that by 1/2. Oop, those cancel. So now what's my new period? My new period is pi. I can see it here, and I could also do this. The period is 2 pi over b. And what was our b? It was 2, see? And then 2 pi over 2. So our period is on this new changed function, this guy right here, compared to normal cosine. This guy's period is pi. Okay? All right, and then how high up does it go? Again, I'm doing this one that I made up right here. It doesn't move up because there's no shift up at the end. There's nothing out here. So this one, I'd start by graphing normal sine, and then I've already changed based on this 2. Now I have to move it to the right pi. How far is pi? That's how far pi is. The whole way. So if I'm going to move it right pi, the whole thing shifts over, and guess what? You end up right back where you were again, because if I continue this out, I think you can see that if I drag it over to the right, this red one, it ends up looking exactly the same, and the part of sine that was originally to the left of it over here is now been dragged over on top of it. So this weirdly doesn't look like it's even been changed, because we moved it over the same amount, pi over 2, as our period. All right, so let's say I was going to do this one. So this is about as brutal as they could possibly get. This part's super easy. Instead of going to 1 and -1 like normal sine would, this is going to go 12 times that. Up to 12 and down to -12. This part, remember me saying we needed to factor that out? 2 comes out. Theta plus, when I divide this by 2, I just have theta. When I divide this by 2, it's like multiplying it by 1/2. And so this becomes pi over 12. If you don't know how I did that, you can just multiply this back out, and you can see that I get my original back again. That if I multiply this times this and this times that, I end up with the original right there. Okay? All right, so I just factored that out. So now my new graph has got this on the inside, which helps me to see that its phase shift, okay, the horizontal shift, the phase shift, is pi over 12. Its period, well, it's 2 pi over b. And what's b? It's 2. So it's 2 pi over 2, which is pi. Its amplitude is 12. And its vertical shift there isn't one. There was nothing on the outside here, so it didn't move up or down. Its A is 12. It's just the number that's right there. Its B is 2. It's the number that's right there. Its C is this number right there, which is pi over 6. Actually, it's after we factored out the 2. So it's that, pi over 12. And last but not least is its D. Its D is the number that would be out here, but there's nothing out there, so that's 0, or you could say none. All right. So there's a basic overview, and I'm going to try to make my videos on the shorter side, but there was a lot to cover there. Holy cow. Aren't you glad I didn't try to cover that all on the first day? So some problems that I'd like you to try. In your homework, you're going to try this one. Don't freak out when there's a fraction in front. Also, when you're graphing these, there's no reason you have to call this spot right there 1. You can absolutely use the top notch, like right up here. You can call that 1. That way your sine graph will look more like this. All right, so I would definitely not try to do it that way. Okay, so if I were you, I'd pick maybe this spot right here is 1, and this spot down here is -1. And then I can pick this spot here to be pi over 2. And then 1, 2, 3, 4, 5, 6, 7, 8. Pick that spot to be pi. And it'll go over 4 more spots. 5, 6, 7, 8 spots. That's where 2 pi is. And this would be 3 pi over 2. All right, should have zoomed in more, but so don't feel like you have to use these as they are labeled, where every little mark is like pi over 2. No, you can pick wherever you want to be pi over 2. All right, so I'm going to have you do 10, 11, 12, and let's see. I'm going to have you do this one. And this one. And this one. And we're not doing that. And we're not going to do that one either. So there you go. That's your homework. Have a great day.